Hello, this is Professor Poyser, and I want to show you how to solve this exponential equation, which is e to the 2x minus 16 e to the x plus 15 equals 0. What the book suggests we do first is we choose a variable like u, and we'll let u equal e to the x. If we do that, you can see that this e to the x right here can simply be replaced with u. So that middle term turns into 16u plus 15 equals 0. But this term over here, this first term, e to the 2x, is not easily replaced with just u. But I hope you see that e to the 2x, I guess I'll write it right here, e to the 2x, could also be written as e to the x quantity squared. That's because this 2 and the x, these two exponents, can be multiplied together to give us 2x. And now maybe it's easier to see that e to the x is this e to the x and can be replaced with u, which means that this now turns into a u squared. So e to the x here is turning into u, and e to the 2x here is turning into u squared. Okay, now that I see the problem like this, that's just a simple quadratic equation that we can solve by factoring. We could also use the quadratic formula, but factoring is the easier way to go. It's faster. So u times u will give me that u squared. Because that's a plus and that's a minus, I know that both of these signs are going to be negative. And the only way to get 15 is 15 times 1, so that when they add them up, you'll give 16, that middle term. Alright, so it's easy to see that I've got two answers of 15 and 1 out of those two parentheses. But we're not looking for u, we're looking for x. So I need to back substitute into these two answers, into these two equations, what u actually is, which is e to the x. Same thing here. Okay, so let me just draw a line in between here because I've got two separate answers going on. The trick that we've learned in class so far to solve for x is to natural log both sides. So I'm going to do that right now. I'll show you that in red. So I'm going to natural log here, I'm going to natural log here, natural log here, natural log there. So I'm natural logging both sides of each equation. Let's handle this one here on the left first, then we'll go and tackle that one on the right. Let's see. The trick also that we learned because of the power rule is I can take this x and kick it out front. So I now have x times the natural log of e is equal to the natural log of 15. And we already know that the natural log of e is simply a 1. So on the left side I have x is equal to the natural log of 15. Hey, there's one answer right there. On the right side, I can do the same trick. I can take this x and kick it out front. So I have x times the natural log of e is equal to the natural log of 1. And I've got two things going on here. First, the natural log of e is simply a 1, so my left-hand side is just an x. But if you try this on your calculator, the natural log of 1, you'll see that that comes out to be a 0, because anything raised to the 0 power will give you an answer of 1. So here's my other answer. I have two answers, natural log of 15 and 0. Natural log of 15 and 0. If your book or My Math Lab requires you to go a little bit further with this and wants you to work out the decimal equivalent, well, you'll find out on your calculator that the natural log of 15, let's say rounded to 2 decimal places, gives you, pull up my calculator here, don't know if you can see that or not, so the natural log of 15 rounded to 2 decimal places gives me 2.71. 2.71. So this answer is going to be approximated as 2.71, and this one here is still 0. So there they are in their natural log form. There they are in their decimal equivalent form. Hope that helps.